Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak and this is Daily Quant with Deepak. Hi all, welcome back to day 51 of 100 days to CAT Quant series. In this video, we'll be discussing 5 questions from geometry. So whenever you come across a question on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video helpful, like the video, share this video with your friends who are preparing for CAT, and most importantly, for more videos, subscribe to this channel. In case if you want to attempt these 5 questions as a test, you can log into our portal, the gurukul.org.in. Right, once you sign up, you'll get access to a course called 100 Days Race to CAT, in which there will be 3 sections: Quant, LRD, and VRs. We'll be uploading 100 tests in each section absolutely for free. So if you're a serious CAT 25 aspirant, you cannot afford missing these tests. So without any further delay, let's get started with the first question. Now coming to the first question, a jogging park has 2 tracks, a circular track which is circumscribed by a triangular track, such that the 3 vertices of the triangle are equidistant from the center of the circular track. Now to this triangle, this is in circle, in center, and it is also mentioned that this point, the in center, is equidistant from the vertices of the triangle. So in center is also acting as the circumcenter of the triangle. So what can we comment about the type of the triangle? Equilateral triangle, right? So we have an equilateral triangle and we have a circle inscribed in the equilateral triangle. Now let the length of the side be A. Then what? A and B start jogging simultaneously from the same point where the circular and triangular tracks touch each other. Now let that point be this, right? So we have A jogging along the circular track, while B jogs along the triangular track, right? Now approximately how much faster than A should B run? Approximately how much faster than A should B run so that they take the same time to return to the starting points. So in the time in which A covers this distance, B should be covering the total triangle, right? So if I consider the length of the side of the triangle to be A, now the length that or the distance that B should cover should be 3A, right? And in the same time, A should be covering this distance. Now what is the formula to calculate in radius of an equilateral triangle? A by 2 root 3. Now if I have in radius, the distance covered by A is nothing but the perimeter of that circle. So perimeter will be 2 into pi into A by 2 root 3. Now these two will get cancelled. Now this is pi by 3 into A. Sorry, pi by root 3 into A. Now we know that the approximate value of root 3 is 1.732 and pi is 3.14, right? So since pi is slightly greater than 3, right? So this should be slightly greater than root 3. So root 3 is 1.732. So I'll be considering this value as 1.8A. So in the time that B covers 3A, A will be covering only 1.8A, or in the time in which A covers 1.8A, B should be covering a distance of 3. Now when time is constant, the ratio of the speeds should be in the ratio of the distances covered, right? So this is nothing but 1.8 by 3, or 18 by 30, or I can further simplify this as 3 by 5, right? So if the speed of A is 3 units, speed of B has to be 5 units. Now what was asked? Approximately how much faster than A should B run so that they can take the same time to return to the starting points, right? So B should be running 2 units faster than A. So 2 by 3 into 100 is close to 66 point, or 60% should be the answer, because this can be slightly less than 1.8 also, right? So 60% should be the answer to this question. Now coming to the second question, a circle C1 with radius R is the incircle of this equilateral triangle ABC of side 12 centimeters. Another circle C2 with the same radius R is drawn touching the circle C1 such that the line joining the centers of these two circles coincide with the altitude of ABC. Right. Line segment MN is drawn such that it lies on the tangent to the circle C2, which is parallel to the side BC, as shown in the figure below. Now, what is the area of the part of triangle AMN which lies outside the two circles? Right. So, all we need to do is we need to first find the area of the triangle AMN. From that, we need to subtract uh, the areas of these two circles, right? Now, since we are given that the length of the side of this equilateral triangle is 12 centimeters, now this is in circle, we can first find the in radius of that triangle, which is 12 by 2 root 3, 6 by root 3. Now, this can further be simplified as 2 root 3, right? So, this will be 4 root 3, this will be 4 root 3, right? Or this, or let this be point D. Now AD is nothing but the altitude of this triangle, right? Now altitude of equilateral triangle will be root 3 by 2 into side into 12, 6 root 3. So this distance is 6 root 3. Now this is 4 root 3. Now since these two are parallel, can I say ABC is similar to AMN, because AMN is also an equilateral triangle. Now since these two are parallel, if this is 60 degrees, this should also be 60 degrees corresponding angles. Now similarly, this is 60, this should also be 60, right? Now these two are similar. ABC is similar to AMN. Now when the altitude is 6 root 3, the side of the triangle is 12 centimeters, right? Now when the altitude is 10 root 3, because 6 root 3 plus 4 root 3, what should be the side, or what is the length of the side? AN, right? So this should be 12 into 10 root 3 by 6 root 3, 2, or this should be 20 units, right? So AN is equal to 20 units. Now, since we have the side of the triangle ANM, we can find its area, right? So root 3 by 4 into 400, which is nothing but 100 root 3. Now from this, we need to subtract the areas of these two circles. Now we know that the radius is 2 root 3. Area of one circle will be pi into r square, 4 into 3, which is nothing but 12 pi. Area of two circles will be 24 pi. So 100 root 3 minus 24 pi should be the answer to this question, hence option C. Now coming to the third question. In quadrilateral ABCD, now let this be ABCD. AB is parallel to CD, BD is perpendicular to AD. Okay, so the diagonal BD is perpendicular to AD, and AC is perpendicular to BC. Now, if AD is equal to BC is equal to 15, so if this is 15, this is 15, right? And AB is equal to 25 units. Then the area of quadrilateral ABCDs. Now, these two legs are of equal length, right? Now, if this is 15, this is 25. This should be 20, because in this right angle triangle, Pythagoras triplets, 3 is to 5. So this has to be of 4 units length. So if 3 units is 15, 5 units is 25, 4 units has to be 20. Now similarly, this is also 20. So these two are congruent triangles. And if we have one pair of parallel sides and the legs are equal in length, right? So when I drop a perpendicular from here, right? Now this triangle is congruent to this triangle, right? Because this angle is equal to this angle, and we have this is common side, this is 90 degrees. So by default, these two should be of equal length, or this is an isosceles trapezium. All right. Now let's find what is this length. All right. Now if I consider triangle ADB, the area of this triangle will be nothing but product of perpendicular sides by 2, half into perpendicular sides, 15 into 20. Now which should also be same as half into the corresponding base, 25, into height, where h is nothing but the height of the quadrilateral, right? So I can cancel these two, 5 threes, 5 fives, 5 fours, or h is equal to 3 into 4, 12 units. Okay, so this is 12, right? Now 12, 15. Now this is a right angle triangle. I can apply Pythagoras triplets. So 4 is to 5. Now this should be of 3 parts. Now if 4 parts is 12 and 5 parts is 15, the 3 parts has to be 9, right? Now similarly, this will also be 9. So if this is 9, this is 9. 25 minus 18, CD, or this part will be same as this part. So this should be of 7 units in length. Now we have the length of the parallel sides of a trapezium, and also we have the altitude of the trapezium. Now what was asked? We are asked to find the area of the trapezium. So half into height 12 into sum of the opposite parallel sides 7 plus 25. So 6 into 32. So 180 plus 12, 192 square units should be the answer to this question. Now coming to the next question. In the given figure, AB is tangent to circle at B and C is the midpoint of the radius OP. So if O is the center of the circle, right, OP is the radius and C is the midpoint of the radius. If length of AB is 10 root 3 and length of AP is 10 units, find the area of triangle ABQ. Okay, right. So we need to find the length of AQ and the length of this perpendicular to answer this question. Right. Now we know that AB square is equal to AP into AQ. Right. So AB square root 3 into 10, 100 into 3. So 300 is equal to AP 10 into AQ. Or the length of AQ is equal to 30 units, right? So this length is 30 units, this is already 10, so this should be 20 units. So the diameter of the circle is 20 units, so radius has to be 10. Now if the radius is 10, now this is 5 units and this is 5 units, right? Now can we find the perpendicular distance? Yes, because in this right angle triangle we have one of the perpendicular sides and the hypotenuse. Now BC square is equal to 10 root 3 whole square, which is 300 minus 10 plus 5, 15. 15 square, 225. Or BC square is equal to 75. BC is equal to root 75. Right? Now we have, BC. And we also have AQ, which is nothing but 30 units. Now what was asked? We are asked to find the area of triangle ABQ. So half into base, 30 into corresponding height, root 75, right? So this is 15. Now I can further simplify root 75 as 5 root 3. So 5 root 3 into 15, 5 15 75, 75 root 3. So hence option B should be the answer to this question. Now coming to the last question. Two circles C1, C2 have radii 10 centimeters and 12 centimeters respectively. Okay. Now if the length of the common chord of the two circles is 18 centimeters. So this is 18 centimeters. What is the distance between the centers of the two circles? Right. So this is 10. This is 12. Now the length of the common chord is 18. Now we know that the line joining centers of two circles in the case of a common chord bisects the chord and will be perpendicular as well, right? Now we know that the length of the common chord is 18 centimeters, so this is 9. So in this right angle triangle we have hypotenuse and one of the perpendicular sides. So the length of this part will be 100 minus 81, which is nothing but root 19. Now similarly, the length of this part will be under root 144 minus 81, which is nothing but root 63. So root 19 plus root 63. So hence option D should be the answer to this question.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's Cat 100 series, Study Room to Boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.